Now we're going to look instead at a vertical shift. So if we had something like this, well, what we're going to see is that since we already know that p of x is just equal to x squared, I can replace the x squared with p of x. And looking at this, it seems to be a little bit more simple here. Whatever the value of p of x is, we're just going to subtract 2 from it. But you notice nothing changed as far as the input goes. So I'm not going to have any horizontal changes in this particular case. So let's go ahead and do that. So at 0, I would normally have an output of 0. I'm going to subtract 2 from that and get minus 2. Now we can verify that by actually plugging it into our equation here, our function. F of 0 is just equal to 0 squared minus 2, or 0 minus 2, which is of course equal to negative 2, getting the same value. But I can just take any of these values here and subtract 2 from them, and that will give me my output for f of x. Once again, what we can do here is simply look at our normal vertex, and we can determine how that would change based off of this minus 2 here. So normally, when I have an input of 0, I get an output of 0. However, I just saw that looking here, when I have an input of 0, I'm going to get an output of negative 2. So my new vertex is going to be at 0, negative 2. Well, if that's the case, again, I see that my x value didn't change at all. However, my y value changed by negative 2. Well, that would be a shift 2 units down. So that's what I'm going to do in general. My transformation for every single point on here is going to be a shift 2 units down. So I can go through to each point and shift it 2 units down. And you'll see that those points match up with my table as well. So, as I mentioned before, since this is happening after the squared part, it is a vertical transformation, and the minus 2 is going to shift every single value down 2 units. That's how you identify a vertical shift.